Our planet Earth is nestled within the Milky Way galaxy, a vast and intricate collection of stars, gas, and dust that forms a magnificent spiral structure. This galaxy, our cosmic home, is just one of the countless wonders in the universe. The Milky Way is a vast collection of stars, gas, and dust, all bound together by gravity. It is a dynamic and ever-changing entity, with stars being born and dying, and clouds of gas and dust swirling in a cosmic dance. On a clear night, far from the bright lights of the city, we can see a band of light stretching across the sky. This band is the Milky Way, our own galaxy viewed from within. It is a reminder of the vastness and beauty of the universe that surrounds us. This band of light is composed of billions of stars, all shining together to create the soft, glowing ribbon we see in the night sky. It is a humbling sight, reminding us of our small place in the grand scheme of the cosmos. But we are not alone in the vast expanse of the universe. Beyond our Milky Way, there are billions of other galaxies, each a swirling island of stars, gas, and dust. These galaxies come in a variety of shapes and sizes, from elegant spirals to massive ellipticals. Each of these galaxies is a universe unto itself, with its own unique history and structure. They are scattered across the cosmos, separated by vast distances, yet all part of the same grand tapestry of the universe. Among these countless galaxies is Andromeda, our closest galactic neighbor. Andromeda is a spiral galaxy, much like our own Milky Way, but even larger. It is a majestic and awe-inspiring sight, a reminder of the grandeur of the universe. Andromeda is currently about 2.5 million light-years away from us. This means that the light we see from Andromeda today left the galaxy 2.5 million years ago, long before humans even existed on Earth. This unfathomable distance is a testament to the vastness of the universe. The light from Andromeda has traveled across the cosmos for millions of years, crossing the immense void of space to reach our eyes. Despite this incredible distance, Andromeda is visible to the naked eye on a clear night. It appears as a faint, fuzzy patch of light in the constellation of Andromeda, a small but significant reminder of the universe beyond our own galaxy. This hazy glow belies the true nature of Andromeda. It is a massive collection of 1 trillion stars, much larger than our own Milky Way. Each of these stars is a sun, with its own planets and possibly even life. While Andromeda may seem like a distant and insignificant object in our night sky, it is on a collision course with our own galaxy. This cosmic event, billions of years in the making, will reshape both galaxies in ways we can only imagine. This colossal collision will create a spectacle of unimaginable proportions in our night sky. Stars will be flung into new orbits, gas clouds will collide and form new stars, and the very structure of our galaxy will be transformed. But before we delve into the specifics of this galactic collision, let's step back and appreciate the grand scale of the universe. The events that will unfold over eons to come are a testament to the dynamic and ever-changing nature of the cosmos. The universe is a vast and wondrous place, full of mysteries and marvels waiting to be discovered. The universe is constantly in motion. Every star, every planet, every galaxy is on a journey through the cosmos, moving in a dance choreographed by the forces of nature. Galaxies, including our own Milky Way and the nearby Andromeda, are not stationary objects. They are dynamic, ever-changing entities, each with its own unique path and story. They are hurtling through space, pulled and pushed by the gravitational forces of other galaxies and the unseen hand of dark matter. This invisible substance, which makes up most of the universe's mass, plays a crucial role in shaping the cosmic landscape. Andromeda's movement through space is bringing it closer and closer to our own galaxy. This impending encounter is a slow-motion cosmic event that will unfold over billions of years. Over the next 3 billion years, Andromeda will gradually grow larger in our night sky. What might seem like a static universe to us is actually a place of constant change and evolution. What was once a faint smudge will become a prominent feature, its spiral arms becoming more defined as it draws nearer. The intricate structure of Andromeda will become more apparent, revealing the beauty and complexity of our neighboring galaxy. The stars within Andromeda, currently too faint to be seen individually, will begin to resolve themselves, appearing as countless pinpricks of light against the backdrop of the galaxy's swirling gas and dust. This transformation will be a spectacular sight, a testament to the grandeur of the universe. The approach of Andromeda will be a slow and gradual process, spanning millions of human lifetimes. It is a reminder of the vast timescales on which the universe operates, far beyond the brief span of human history. For countless generations, humans could look up at the night sky and witness the slow, inexorable approach of this celestial giant. Each generation will see Andromeda a little closer, a little larger, a little more detailed. The sight of Andromeda looming larger with each passing century would be a constant reminder of the dynamic nature of the universe and the fleeting nature of our own existence. It is a cosmic event that connects us to the broader universe, reminding us of our place in the grand scheme of things. As Andromeda draws closer, its gravitational influence on the Milky Way will begin to increase. This interaction will have profound effects on both galaxies, altering their shapes and triggering new waves of star formation. This gravitational tug-of-war between the two galaxies will distort their shapes, pulling out long streams of stars and gas like taffy. These interactions will create new structures and features within both galaxies, reshaping them in ways we can only begin to imagine. These tidal tails, as they are known, will be visible in the night sky as faint, ethereal streamers of light, stretching across vast distances. They are the cosmic fingerprints of this galactic encounter, a visual record of the forces at play in the universe. Within these tidal tails, new stars will be born. The gas and dust pulled from the galaxies will collapse under gravity, igniting new stellar nurseries. These new stars will add to the rich tapestry of the night sky, a legacy of the Andromeda Milky Way encounter. The night sky of the future will be a dynamic and ever-changing canvas, painted with the light of new stars and the remnants of ancient galaxies. It is a reminder that the universe is not static, but a place of constant creation and transformation. Eventually, the Milky Way and Andromeda will merge, forming a new galaxy. This cosmic union will mark the end of one chapter and the beginning of another in the story of the universe. The new galaxy will be a testament to the power of gravitational forces and the ever-evolving nature of the cosmos. The merged galaxy will be a spectacular sight, a blend of stars, gas, and dust from both the Milky Way and Andromeda. It will be a new home for future generations of stars and planets, a new chapter in the ongoing story of the universe. The initial stages of the Milky Way-Andromeda collision will be marked by a series of close encounters, a celestial dance on a cosmic scale. These encounters will be slow and majestic, taking place over millions of years, as the two galaxies gradually draw closer to one another. As the two galaxies approach each other, their gravitational forces will begin to interact, creating intricate tidal streams of stars and gas. These streams will stretch across vast distances, connecting the two galaxies in a delicate, luminous web. This gravitational interplay will distort the shapes of both galaxies, pulling out long, luminous tails of material. These tidal tails will be composed of stars, gas, and dust, and will be visible as faint glowing arcs in the night sky. From our vantage point on Earth, the night sky will transform into a breathtaking spectacle. The familiar constellations will be joined by new temporary patterns of stars as the two galaxies interact and merge. The familiar band of the Milky Way will warp and twist as Andromeda's gravity exerts its pull. This warping will create new, intricate patterns in the night sky as the stars of the Milky Way are drawn into new positions. Streams of stars, like celestial rivers, will flow across the cosmos, creating intricate patterns against the backdrop of distant galaxies. These streams will be visible as faint, glowing lines in the night sky, connecting the two galaxies in a delicate, luminous web. However, it's important to remember that galactic collisions are not like car crashes. The vast distances between stars mean that direct collisions between stars are extremely unlikely. Galaxies are mostly empty space, with stars scattered far apart. This means that while the galaxies themselves will collide and merge, individual stars are unlikely to collide with each other directly. This means that while the galaxies themselves will collide and merge, individual stars are unlikely to collide with each other directly. Instead, the stars will pass by one another, their paths altered by the gravitational forces at play. As the two galaxies continue their dance, they will pass through each other, their stars mingling like dancers on a crowded floor. This mingling will create new patterns of stars, as the stars of the two galaxies are drawn into new positions. This passage will trigger waves of star formation, igniting vast regions of gas and dust. These waves of star formation will create new, bright regions of stars, illuminating the merging galaxies with the brilliant light of newborn stars. These new stars will be visible as bright, glowing regions in the night sky, adding to the already breathtaking spectacle of the galactic collision. The collision between the Milky Way and Andromeda will be a slow and drawn-out process, but it won't be without its moments of intense activity. As the two galaxies merge, vast clouds of gas and dust will collide, triggering bursts of star formation on an unprecedented scale. These star-forming regions, known as starburst regions, will light up the merging galaxies with the brilliant blue light of hot young stars. These stellar nurseries will be the birthplace of millions of new stars, each one a fiery furnace fusing hydrogen into helium and releasing vast amounts of energy. The most massive of these stars will live fast and die young, exploding as supernovae in spectacular displays of cosmic fireworks. Supernova explosions are among the most energetic events in the universe, briefly outshining entire galaxies. During the Milky Way-Andromeda collision, these supernovae will be visible from Earth as brilliant points of light, appearing suddenly and fading away over weeks or months. The intense radiation from these supernovae will ionize surrounding gas clouds, causing them to glow with vibrant colors. The night sky will be ablaze with these glowing nebulae, painting a breathtaking tapestry of